Good evening, students. Today, let us understand the concept of grouping of resistances. That means we know it in your capacitance. That is how the capacitors are connected in a circuit to give the desired value of the capacitance of the circuit, or how much charge we need in our circuit. Depending on that, the capacitors were connected. So in your chapter 2 we have learned it. Now in here let us understand the concept of series and parallel grouping of resistances, so that in any given circuit we can have our desired value of the current by combining appropriate number of different values of resistances given to us. So for that only we need to know the series and parallel grouping of resistances. Just like this, series grouping means it's a cascaded style of resistances connection. Like suppose you have, for simplicity, you take two resistances like this. They are connected to a battery like this. The resistance here it is R1 and here it is R2. I am discussing, first point I am discussing it, your series grouping of resistances. First one is your series grouping. Two resistances I have taken. I have taken a battery here V. So let us understand the current flow. It is a positive terminal. So all the time you start a current that will come out of these batteries positive terminal. Let's say the current coming to this current coming from this terminal, it is I. It means this definitely the same amount of current will enter here. It's a your equation of continuity. So this current will come here in this circuit. There are two resistors given. Resistors means otherwise they are called circuit breakers. So R1 means if they have high value of resistance in comparison to your other branches of the wiring. This kind of grouping of resistances, they are called series grouping of resistances. Got? They are back to back, and you see this amount of current, whatever flows through the resistance R1, the same amount of current flowing through your R2, and they are connected back to back like this. How back to back? The positive terminal of the battery is connected to one end of your resistances, and you see this positive terminal, let's say the battery voltage is 5 volt. The battery voltage, if it will be 5 volt, let us, for simplicity, let us take this terminal to be at 0 volt and this terminal to be at 5 volt. 5. So the difference is 5 minus 0, so it is a 5 volt battery, let us take for simplicity. So if this potential 5 is here, means if you move from this point along the circuit and coming here, you see you are started moving from this terminal. The potential here is 5. If you go in this way and take a round trip and come here to this point, the potential here it is 0. Means you have started from 5 and coming to this point to a 0 potential. So means the value of the potential decreases gradually as you move along the circuit. Got? So resistances are the your elements, circuit elements. Because of that, the voltage in a circuit they dropped. Means the function of the resistance is to reduce the potential difference, reduce the potential. Like you see, suppose the potential at this point is 5, it means the potential here it is 5. Now if a resistance is here, it will drop some potential, so definitely the potential is less than 5 here. Here the potential is less than 5 and the potential of this point and this point are same, and again as a resistance is given, so it will, let's say the potential here, for simplicity it is 3, here the potential is 3, here the potential is 0, let's say. Getting my point? So you see here the potential is 5 here as it is connected to the positive terminal. Here the potential is 3, because this the job of a resistor is to decrease the potential. So if it is 5, it is coming to your 3. Now at this point the potential is 3, and at this point the potential is 0, as it is decreasing the potential. Why it is 0? Because already we have taken this terminal is having your 0 potential. Got? So if the two resistors they are connected like this, they are called your series resistances. And for two series resistances, you see I have taken here, the current through that resistances are same. Now we can see here, in this case, the net voltage in the circuit, or we can draw the simplified diagram. We can draw the simplified diagram here by just replacing the two resistances with a single resistance, and the purpose of that single resistance is to replace the two resistances. It means here the battery is sending I amount of current to the circuit. The same battery is connected here. The same battery in this case also sends I amount of current to the circuit. And here you see, if the resistance is Rs, then I can say Rs is the equivalent resistance of the R1 and R2. So in this case you see, as this resistance is connected directly across the battery, so the total battery voltage, you take it to be V, which is nothing but the potential drop across this resistance and the potential drop across that resistance, resistance 1 and resistance 2. So it will be V1 plus V2. V1 is what? The potential drop or potential difference across the resistance R1, and V2 is the potential difference across the resistance R2. And we know, according to your that mathematical relation, V and I and R, V is equal to IR. So here I can see, right, V is equal to here I into Rs. In this case, see, both the resistances, they have I amount of current flowing through them. So here it is I into R1 plus I into R2. So which implies Rs is equal to R1 plus R2. So this is the formula for series grouping of resistances. If n number of resistances are connected in series, then the formula will be Rs is equal to like R1 plus R2 up to Rn. And for n identical resistances, if R1, R2 up to Rn all are equal, then you can say it would be n into R. Got? So this is your series grouping of resistances. Now come to your parallel grouping. For simplicity, I will be taking only two resistances connected across a battery in parallel grouping. So we can write here parallel grouping of resistors, or simply parallel grouping. As already told to you in your chapter capacitance, in the same way we can write here. Suppose two resistors are given. One is like this, another resistance is, if it is R1, if it is R2, parallel means two ends, they are connected like this. Means the two, one end of R1 and one end of R2, they are clubbed at one point, and the other end clubbed at the other end. So this type of connection, they are called your parallel grouping. Let us take a battery here. The battery here, it is, let's say V, if it is plus, it is minus. So the battery will send some amount of current to the circuit, let's say it is I. The current will come here. Again, as only one way is there, so in this branch also current I will flow, and here also in this, from here to here also the I amount of current will flow. See, as the potential here, let's say I am taking it to be V, means you can take the potential here, it is 0, and the potential here it is V, means the potential difference is V here. We can say, as this positive terminal is connected to this point, so the potential at this point, let's say that mark that point to be A and this point to be B. So point A, the potential is V, and at point B the potential is 0. So the potential difference across R1 is V minus 0, which is V. Across R2 it is also V. Means in parallel grouping, the potential difference across all the resistances must be same. But what about the current? You see, the current I is coming here, and the current finds two different ways. One way this, another way this. Suppose in this branch, I1 amount of current is flowing in this branch. So let's take it to be I2, and in this branch, I1 amount of current is flowing. Clear? Students, you remember, from this point the current gets distributed. Got? So there is a rule, whatever current is coming to a junction, the same amount of current will just go from that junction, go out of that junction. So it means simply, in simple case, we can write here, the current I will be I1 plus I2. The sum of these two currents must be equal to the current supplied by the battery. Now we can replace the two resistances with single resistance, that is called the effective resistance. If through that resistance same I amount of current can be sent by the battery, then only we can say that resistance, that single resistor, will solve the purpose of the two resistances, and that single resistance is called your equivalent resistance in parallel. So let us draw the diagram again. Suppose I will be replacing that 2 by a single resistance, and the battery is connected here like this. Let's say the single resistance here it is Rp, and the terminal here it is plus and here it is minus. From this end, let's say I amount of current is coming, so the same I amount of current must enter here. So see, through this Rp again I amount of current will flow, and across Rp the potential difference is V. The battery is sending I amount of current to the circuit, there also it is same. Since the current in both the circuits are same, we can say Rp is the equivalent resistance of the two resistors. So in that case, we can say I is equal to the sum of I1 plus I2. Here also I amount of current will enter to the circuit. I is equal to I1 plus I2. Again the same formula we can apply. V is equal to I into R. So I is equal to V upon R. Try to understand. In parallel grouping, you see the two ends as they are clubbed to this point. The potential difference across this, it would be V, and across this resistance it would also be V. So we can say here, which is V by Rp. For I1 we can write V by R1 plus I2, it is V by R2. So which implies 1 by Rp is equal to 1 by R1 plus 1 by R2. So if only two resistances should have been there, so there is a shortcut formula you remember for Rp. For Rp the formula is R1 into R2 by R1 plus R2. Only for two resistances this formula is valid. It's a shortcut formula, but you remember it. For n number of resistances the formula would extend up to n number. So 1 by Rp is equal to 1 by R1 plus 1 by R2 up to 1 by Rn. So for n identical resistances we can write here. So 1 by Rp is equal to n identical resistances, 1 by R plus 1 by R plus 1 by R. So it should be n by R. Means n number of R's, 1 by R's. So that is n by R, or which simply implies Rp is equal to R upon n. So which is the simple formula. So this is your parallel grouping of resistances. Thank you.